Hello. Welcome to this lesson on systems of linear inequalities. Please like this video if you find it helpful, subscribe to the channel for more math help, and check out the other videos and playlists on the channel. We have all kinds of things to help you in whatever questions you have regarding your math. So let's take a look at this. We're going to talk about systems of inequalities. This is a kind of a weird little topic. I mean, they look cool. They're definitely impressive to look at, but we might need a little bit of explanation on what exactly is going on here. So first of all, systems of linear inequalities or any kind of systems of inequalities are really only solved by graphing and showing a picture of the solutions. So we would just show what the solution set is. We would not list a solution set. And usually that's because there are infinite solutions, because we're going to be shading in whole regions of the coordinate plane. Now, there might be some cases where the things that you're looking at are only integers, and therefore you could list out all the possibilities if the region was small enough, but that would be the exception, not the norm. And essentially what we do is we solve them by graphing both inequalities on the same coordinate plane and showing the region of the points that satisfy both. So a lot of this really comes down to understanding those basic key ideas that I talk about so much in these videos, that the graph shows all of the points that will make an inequality true. If you have a system of inequalities, then you want all of the points that make both of the inequalities true. Therefore, you're going to like shade some for one and shade some for the other and look at what's shaded for both. So I've got this example kind of laid out across the bottom of the screen here, but here's my system of inequalities right here. So typically you would see them stacked over each other, but I have them side by side because I'm going to put the graphs underneath them. And we have y is less than 2x minus 3. So that's our first inequality. The second inequality is y is greater than or equal to negative x plus 1. And then we're going to show the solution to the system. So the graph for the first one looks like this. So we can take a close look at that. We've got a y-intercept of -3, a slope of 2. It is a less than, so we're using a dotted line, and it is less than, so we're showing like the bottom. Okay, now if you need to review how to graph an inequality, please check out that video. I'll see if I can link it here. If not, I'll link it in the description box, but please go and check that out. If you're like, wait, how did you get that? I don't know that. I'm going to go back and check that out. We are assuming that you can graph the inequality. So we've got the dotted line. We're shading underneath the dotted line, and that represents the solution to the first inequality. All these points that are shaded, every single one of them will make that inequality true. Now we have the second inequality, and we'll notice this one has a y-intercept of 1 and a slope of -1, and it has an equal to, so this will have a solid line instead of a dashed or dotted line, and this is greater than, so we are shading above the line. So these are all the points that make the second inequality true. So if you were asked to graph the system, here's what it would look like. You would put both of those graphs on the same coordinate plane. And I really like how Desmos does this. These graphs came from Desmos, where you can clearly see the region of overlap. So we had like this purple section, and then we had this reddish section, and here's the region of overlap. These are the points that make both of the inequalities true. Okay, and so this is our solution. Again, we only solve these by graphing. Okay, we show the solution on the coordinate plane, and we say this, like this region of the coordinate plane represents all of the points that are solutions. If a point is on the red line down here, it is a solution. If it's on the purple line, it is not a solution, okay? And if it's on the red line, but it's up here, it is not a solution. So that's something that often I'll see will trip students up. So that's basically what we're doing. So if you can graph an inequality, then you can certainly graph a system. You're just going to do more than one on the same coordinate plane. And I'll give you some pointers and tips about, how to go about doing this as we move through. All right, I don't know what happened. I had to pause the recording halfway through this problem, and then it like just wouldn't record again. So hopefully this is a smooth transition, but we're going to do one of these by hand. So we have two inequalities there. I'm going to start with the second inequality, not because it's like I have to, but because this one is in slope-intercept form. So I just know I can graph it a little bit faster. So this is y is less than 4x minus 1. So the y-intercept for this one is -1. So I'm going to come over here and plot the -1. And the slope is 4, or you can think of that as 4 over 1. So I'm going to go up 4 and right 1. So up 1, 2, 3, 4, and right 1. Now, normally if I were just doing a line, I would leave it at that. I am going to do that up 4, right 1 a couple more times, and then I'm also going to go down 4, left 1, so that would be like -4 over -1, because there's going to be shading, multiple shading, and sometimes the shading will obscure some of your points, your dots that you're making, and making them a little bit harder to see. And if your teacher is going to be grading it, you want to make sure that the teacher can see everything he or she needs to see in order to grade your work. So you don't want to have your points covered up. So just to be sure, I'm just going to count up 1, 2, 3, 4 and right 1. And I'm going to go down 1, 2, 3, 4 and left 1. I think I can do that again. 1, 2, 3, 4, left 1. This is just a less than, so it is a dashed line. And if you recall from our lesson on inequalities, we're looking at the y is less than. So y gets greater as you go up and less as you go lower. And so this is a less than. So I want to shade the side of the line that has a less than. So as I'm doing that, I am just using the red pen here, and I'm just using a set of lines that all go in the same direction. Now, make sure that you cross the x-axis and the y-axis. I have had students do some odd things where they might shade like just in here, and then they stop at the x-axis. So the only thing that's going to cause you to stop is that red line right there. Like you're not going to stop at the y-axis. You want to make sure you get like that little chunk in there. You're not going to stop up here. That you are. Now, if you're doing a colored pencil, you might do something like this where you shade it in. Now I'm not going to do that because the red is going to be very, very dark on this, but you could grab your colored pencil and then like lightly shade in everything in the same color and just kind of do like a light shading, and you can make it look really pretty and all the things. All right, for the next one, I'm going to use the blue. Okay, and this one is not in slope-intercept form. So I'm going to put it in slope-intercept form because I like that better. I'm going to start by subtracting 2x from both sides. 2x minus 2x is 0, leaving me with 3y. Now I could write 3 minus 2x, but I know I'm going to want that x in the front spot there for my slope. So I'm going to write -2x plus 3. And divide everything by 3. That I am dividing by a positive, so I do not need to flip my inequality around, but be mindful of that. And so now we have the y is less than or equal to negative 2/3 x plus 1. So we have a y-intercept of 1. And this time the slope is negative 2/3. So I'm going to go y-intercept is 1 and the slope is negative 2/3. So we're going to go down 2 and right 3. So down 2, right 1, 2, 3. And you'll notice that this blue dot that I just did, it's like right in the middle of the red shaded region. And that's why I said you might want to do more points. You kind of want to go light on your shading, because if you color that in super, super dark with the red, then you might not be able to see where you want that point to go. And we'll do this again. We'll go down 1, 2, right 1, 2, 3, down 2, right 1, 2, 3, and I'm going to go up 2 and left 1, 2, 3, and just get my points going in this direction. 1, 2, 3, up 2. And this one does have the equal sign underneath it. So this one will be a solid line, but you might have 2 solid lines. You might have 2 dashed lines. This one has 2 less thans. I try to change it up a little bit. Kind of as when you're writing these problems, you tend to be like, oh, I'm going to do a less than and a greater than. I'm going to do one that's dashed and one that's solid in each problem. And then sometimes students think, oh, it's always got to be that way. And it does not. always have to be that way. So this one is a less than. So we are going to shade the less than side. And so I'm going to do this with lines. And these lines, you'll notice, are going in a different direction than the red ones. Now, you can also do like a nice shading with your highlighters or with your colored pencils. So if I were doing this like shading, okay, I might have one color shading and then I might have another color shading over it. And yeah, now what I don't like about this is that the shading like obliterates. But typically if you were doing this with colored pencils, it would continue to look like that, where you could see where is one color, where's the other color, and where's the overlap. And that's what Desmos does as well. This just kind of obliterates that when you're done. Now, if you only have one color that you're working with, so maybe you just have a pencil, this little trick with the direction will create a hash mark sort of. And so you'll have the section that's only blue, the section that's only red, or you'll have the section that's only lines in this direction, section that's only lines in this direction, and then you'll have this area of crisscrossiness, and that's the chunk that is a solution to both. And if you think it's unclear, write your teacher a note. This here, like just that region right there, that's the one. Make sure that you can see the dots for the lines. You can see whether the lines are solid or dashed lines, and that the region of overlap is very clear. I typically like my students to show all 4 regions. So I want to see which region does not have any shading, which one is just each color, and which one is the overlap. And the reason I like to see that is some online like math aids will only show the region of overlap. And I know that if a student is constructing this by hand, chances are that they're gonna need all of the regions there. All right, so we're going to look at a couple of applications. So this one is going to review horizontal and vertical lines. So this is a little bit different, but it's a good application. To get into your first choice college, you need a GPA of at least 3.0 and an SAT score of at least 1150. Graph the qualifying scores on the coordinate plane. So for our first one, we've got our GPA of at least 3.0. So what I'm going to do is draw, notice where GPA is. GPA is going to be on my x-axis. And so you could think of this as x. Your GPA has to be greater than or equal to 3. And that's going to end up being a vertical line going right down there, and greater than or equal to 3 means these GPAs out here. These are your qualifying GPAs, so they're going in that direction. An SAT score, notice our SAT scores are on the y-axis, and this has to be at least 1150, so our y has to be greater than or equal to 1150. Now this is a horizontal line, and probably it's been a while since you or us we've looked at horizontal and vertical lines. This is a nice little review. You can think of that as a slope of 0 and a y-intercept of 1150. 1150 is going to be right here in between the two. And SAT scores above that are going to be in this direction. So your solution set, so if you are looking for like what is the solution set, it's this region of points right there. Okay. And so I've done this problem in class before, and I'll kind of go through the different regions. So this region down here, it means that you're not going to go to that school, okay? I don't know what kind of athletic scholarship you need to overcome this, but this would be you don't have the minimum GPA and you also are not meeting the SAT threshold. You're meeting the GPA, but you're falling short on the SAT threshold. And sometimes like you can still get into a school because they look at more than just your GPA and your SAT scores. So this is like a limited example, but they will look at like your clubs, your extracurriculars, your sports, athletics, if you are a star athlete, as long as you're maybe coming close enough. Now, if your SAT score is like a 600 combined, you're going to need to work on that before you apply to your first choice school year. But if you are close you might still be able to get in. This region over here, you've got the SAT score, but you are falling short on the GPA. And that's when somebody might say, hey, you're going to need to take some honors classes. We're going to need to do some stuff to get your GPA up a little bit higher. But I think this is a pretty good example, because most students taking Algebra 1, if you're in Algebra 1, you might have college is a ways down the way, but we also do problems like this in Algebra 2, which would be a lot closer, and you can really see what the different regions represent and how this is a system of inequalities. Okay, so I had another problem, but there's a little bit of an issue with how that is phrased. So I don't want to get tangled up in the weeds with that, because like there was like a phrasing issue on that particular problem there. So let's go to like a couple of pointers on this. When you're doing these, shade lightly but clearly. So pick a color, pick a line, like a directional line, and shade lightly but clearly. And then when you're done with the problem, if you think that the area of overlap is not clear, you can always go back and darken up that area, but make sure everything is clear. Make sure lines and points used to graph the lines are visible, okay, that you do not shade over them. And I have seen students do like this kind of move, and I probably mentioned this in some of my other videos, where they go to shade, and when they go to shade, they shade right on top of the line. And so it becomes very, very difficult to see what's going on. If you only have one color or think the region of overlap isn't clear, make a note on your graph. So communicate with your teacher about what you intend to be your answer. And in application problems, try to express in words what the different regions of overlap means. So like we did with the SAT and the GPA, like what do the 4 categories mean, to evidence that you understand the entire problem. All right, so don't forget, like and subscribe if you found this lesson helpful. Check out the practice set for this lesson. I will link that in the description box, because there's a couple, at least one good application problem in there that is worth checking out. Drop a comment or question below, and check out the other videos and playlists on the channel. And I will see you in the next one.